One of the things that we study in geometry is the area of a regular polygon. We define area of a regular polygon as 1/2 p times a, or pa divided by 2. And p represents the perimeter of the regular polygon. We'll develop a formula for this later on in the video. Now there's some important vocabulary that you need to understand in order to be able to work these problems with ease, so let's talk about those. First, you need to know that regular means that the polygon has congruent sides and congruent interior angles. You'll also need to know that the apothem is the perpendicular distance from the center of the regular polygon to one of the sides. There's also a radius, which is the distance from the center of the regular polygon to one of the vertices. Now here you should notice this creates a right triangle. For this video, we'll call the base of this right triangle S. Because this is a right triangle, we can use our basic trig ratios to write an equation relating the two legs of this little right triangle, A and S. So let's use this top angle as our reference angle, and we'll call it theta. We could call it x, but traditionally we use Greek letters to represent unknown angles. Since tangent is opposite over adjacent, the tangent of angle theta equals S over A. Now I know that people don't like fractions, especially if there's a variable in the denominator, so we can rewrite this equation by multiplying both sides by A, which leaves us A times the tangent of theta equals S, or S equals A times the tangent of theta. Now this angle theta is going to be half of the measure of the central angle. So if we define n as the number of sides of the regular polygon, then the measure of this angle theta is 360 divided by 2n. So now let's define perimeter. Since a regular polygon has equal side lengths, the distance around would just be the number of sides times the length of each side. Since we've defined S as half of one of the sides, the length of one side would be 2s. So using variables we've already defined in this process, we can say that perimeter is equal to 2s times n. Now there's a ton of information on this screen, a lot of variables, a lot of equations, so what does it all mean? Basically, if we know what kind of regular polygon we have, or how many sides it has, and the area, we can solve for the apothem or the perimeter using a system of these three equations. Solving a system of equations involves a lot of substitution and a lot of algebra, so I'll show you some examples. Before we get to any actual examples, I want to simplify this system a little bit. With these problems, we're using area to solve for either the apothem or the side length. So it's important to note that the capital A is going to be a number and not a variable. We're also going to know what type of regular polygon it is, so n is also going to be a number and not a variable. So by substituting 2sn in place of perimeter in the area equation, this drops us down to a two-variable system of equations, where our unknowns are s and a. Now before we start substituting our known values for area and number of sides, let's actually simplify this top equation a little bit. This equation for area is represented as a single product with all the numbers and variables already multiplied together, so there's no distributing in order to be simplified. Since the product of 1/2 and 2 is 1, those two numbers cancel each other out. Let's remember that we will already know the value for n for this type of problem. So our next step in simplifying this equation is to isolate the variables on one side and the constants on the other by dividing both sides of the equation by n, which leaves us with capital A divided by n equals s times a. By substituting 2sn in place of perimeter in our original area equation, we've created a simplified system of equations to help us solve these problems. In this example, we're to determine the perimeter of a regular hexagon with an area of 259.8076244 inches squared. Now I know that starting out with a crazy decimal number like that can be really intimidating, but this example is designed so that the answer will work out to a nice whole number for us. So the area actually has to start out in this kind of format for us to have that nice integer answer at the end. Now, that's not always the case. We cannot assume that because we start out with a big decimal number, we're going to end up with a nice whole number. But like I said, that is how this example was set up. To solve this problem, we're going to use the simplified system of equations we developed earlier. The first thing we're going to do is plug in the values that we know that are given to us in the problem. So I'm going to substitute 259.8076244 in place of capital A and 6 in place of n, since a hexagon has 6 sides. Then I'm going to use a calculator to simplify the numbers. So my system of equations is now 43.3013 equals s times a, and s equals a times the tangent of 30 degrees. Now this problem is asking us to determine the perimeter, which means that we need to solve for s. So we'll want to substitute a out of the first area equation. To do this, we will algebraically manipulate the tangent equation to isolate a so that we can substitute the equivalent expression in place of a in the other equation, which will leave us an equation with a single variable s. Here we have a quadratic equation to solve, which would normally generate two solutions, but in this case, we'll only consider the principal square root since even a partial side length of a polygon must be positive. Now that we have the value of s, we can double it to get the length of one side of the regular hexagon, and then multiply by 6 to get the perimeter. For this example, we're asked to determine the length of the apothem of a regular octagon with an area of 53.019336 inches squared. Once again, we're going to use the simplified system of equations we developed earlier. We'll start by substituting in the values that we know. So we'll plug in 53.019336 in place of capital A and 8 in place of n, since an octagon has 8 sides. Since this problem is asking us to determine the apothem, we need to solve for a. So we'll want to substitute the expression equivalent to s from our tangent equation into the other equation in place of s, so that we'll have an equation with a single variable a. And once again, it's a quadratic. And just like in the previous example, when we solve by taking the square root, we're only going to need the principal square root, or the positive one. So the length of our apothem is 4 inches. If you have any questions, let me know in the comment section below. Thanks for watching.